Hey Internet, welcome to Thermodynamics tutorial. This is a made-up question not found in your textbooks. With a piston-cylinder device containing 0.86 kilograms of refrigerant 134a, initial temperature minus 10 degrees Celsius, the piston is free to move, the mass of the piston is 13 kilograms, the diameter is 26 centimeters, the atmospheric pressure is 89 kPa, heat is added until the refrigerant reaches 15 degrees Celsius. We want to find the pressure at the final state, the change in volume of the refrigerant, the change in enthalpy of the refrigerant. Step 1, draw your free body diagram, your FBD. This will help you visualize the problem. Piston cylinder device, refrigerant 134a, has a mass of the refrigerant of 0.86 kilograms, initial temperature minus 10 degrees Celsius. Heat is added until it becomes 15 degrees Celsius. Step 2, list all the given variables, find the unknown. So once again, pressure, change in volume, change in enthalpy, and all the values that are given in the question. Step 3, find the pressure formula. So we know the final pressure is equal to the initial pressure because none of the values that is calculated in the pressure formula changes. So all of these are constant, the mass is constant, gravity is constant, the diameter is constant. So none of those change. That's why initial is equal to final. Also, the atmospheric pressure doesn't change. Alright, step 4, find the pressure. So convert your centimeters to meters by dividing by 100. You want your units to match. So just plug and play. So everything is given in the question. So we know it's a circle because it's a piston. So we're using pi multiplied by diameter squared divided by 4. So plug this into your graphic calculator. You'll get 91.4 kPa. Step 5, find the change in volume formula. So delta V, the delta represents change. Capital V, because we are multiplying with the mass. So mass multiplied by the change in specific volumes. Final minus initial. Alright, so step 6, find the specific volumes. So what you're going to do is you're going to go to your property table. You're going to use your pressure and temperatures for both the initial and final state. You will realize that your property table, that these specific values don't exist. 1, because this is a made-up question. 2, because in the textbook question, they actually want you to practice using the thermodynamic software. However, in this case, we're going to use open source code. So I just wrote some code that will give you these values. And I will show you briefly. The code is in the pinned comment. It's only 66 lines. If you want the original engineering equation solver code, that's also in the pinned comment, but I can't show you that. So I can show you my code that's original, but I can't show you the EES code. Okay, so here's the values, and now I'm going to go to Python and just run the code. So as you can, it's actually 52 lines of code, so it's pretty short. Okay, so you can take a screenshot just in case it's not in the pinned comment. Okay, so I'm running it. So as you can see, the initial state, final state gives you the specific volume, and while we're here, it'll give you the specific enthalpy as well. Okay, and this code also calculates the changes. You do need to multiply the mass to get the answers for part B and C, but we're almost there. Okay. So you got your specific volume values from the software, or you just wrote your own code like me and you did it that way. Either works. Would your professor be impressed, or would they be mad? It depends. I think they would prefer you to use the engineering equation solver code, but Python's the same. Let's be real. Code is code. It does the same job. Okay, so step 7, find the change in volume. So you grab the values from your software readings or printout, then you multiply by the mass, and you'll get 0.0205 meters cubed, and that's the change in volume. Step 8, find the change in enthalpy formula, similar to the change in volume, but we're using enthalpy, so final minus initial specific enthalpy. Once again, we're going to use the software. So as you can see, it's already done it for us. So step 9, use the software using both the final and initial states. So this one's final, this one's initial. Okay, and then step 10, find the change in enthalpy. So mass multiplied by the specific enthalpy, final minus initial, we'll get 17.6 kilojoules. Disclaimers: the method is correct, however, I do make calculation mistakes. I encourage you to solve it yourself and see if you get the same answer. Now, before we leave, I highly encourage you to save this video onto your PC just in case this video or channel gets taken down. While I follow all copyright laws, sometimes things happen. You can do this by using Snipping Tool. If you never used Snipping Tool before, follow these instructions. If you're on a Mac, use the Mac equivalent of Snipping Tool. Click on the icon in your taskbar. If it's not there, go to your Windows search, type in Snipping Tool, open up the program. Once open, click on Video option, click on New. Left click and drag the rectangle to cover the YouTube screen. This is just an example. Hit the start button in Snipping Tool, wait for the countdown, hit the replay button on YouTube, let the video finish, hit the red square in Snipping Tool to stop recording, and then save your video. Thanks for watching. Hope you had a great day. Be sure to like and subscribe. Share with your friends because this is a made up question, so they probably won't be able to find it. If you got questions, comments, or if you find a mistake in the video, leave it in the comment section below. If you want to support me, become a member or drop a super thanks. Until next time, see ya.